Hi everyone, in this video we are going to discuss nuclear waste, finally, right? So up until this point we've discussed the schematic of a nuclear power plant, we know what the reactors are, we know how the cooling systems work, we know how everything works in the nuclear reactor, including what happens if there's an operator error and we have some kind of explosion, but the one thing we haven't addressed is the actual nuclear waste. So that's what we're going to do in this video. And so it's going to be in two different parts. We're going to talk about the actual waste and then the actual storage process for it. So there's three different pieces of waste that you need to be very, very familiar with. The first one is your high level radioactive waste. And usually when we refer to this, people just write HLW, okay? High level radioactive waste. So this is a very specific definition. It is considered dangerous chemicals. And when we say dangerous chemicals, we are primarily referring to what are called acids and bases, okay? And we are also referring to radioactive materials. This is definitely something that would be considered an international security risk, and that is highly to do with the fact that there is plutonium and uranium all around high-level radioactive waste. So these are big international security risks. All right, the second one, instead of high level, we have low level radioactive waste. And just like I would think you would expect, instead of being HLW, this is LLW. And this is actually 90% of the waste that's created from a nuclear power plant. 90% of it is considered low level. So these are your gloves. These are any smoke detectors that are inside of those reactors or the plants. Smoke detectors. We also would consider these low radioactive materials. And like I said, but this is important, so I want to write this out, 90% of waste at these nuclear power plants is considered low-level waste, all right? So the majority of it is low-level, which is nice. And then the third thing we want to talk about is SNF, or spent nuclear fuel. SNF. So basically, these are old fuel rods, or fuel rods that have been in a reactor. They're used up, they're spent, we're done with them, but they still have a lot of issues, and so we have to address them and store them carefully. So let's break this down piece by piece. Usually, these spent nuclear fuel rods have about 1% of uranium-235 inside of them still. What that means is there are lots of fission byproducts. Okay, these things are not safe. You do not want to be hanging around spent nuclear fuel rods if you can avoid it. We also know that there is plutonium-239 in here, which is a huge international security risk. And the last thing I want to point out, and this is more just kind of a fun fact for this, is that usually fuel rods at a reactor are replaced, okay, annually, and it's about 30% of them are replaced annually, I should say, okay? So just so you have an idea that every single year, 30% of the fuel rods that are used are taken down and they're stored somewhere, and we'll talk about that in just a second. But before I want to do that, I want to make sure this is very clear from these three. Of these three types of waste, which one is not considered an international security risk? Okay, you only have three options. Go. All right, did you get the right answer? Hopefully you did. There were only three options, so you had a 33% chance of getting it right. And the correct answer is definitely your low-level waste. So 90% of our waste is not considered an international security risk. Unfortunately, that means 10% of our waste is. And that is because it has these highly reactive, radioactive isotopes sitting there that if somebody that was maybe a little bit evil got their hands on it, it could be really, really bad. And they could possibly, with a lot of work, convert it into a nuclear weapon. So now I want to focus on what we do with these spent nuclear fuel rods. So these SNFs, how do we actually store them? What do we do with them once they're done? So this section is just going to be SNF storage. And this is always threefold. The first thing that they do is you store your SNFs, your spent nuclear fuel rods, in a water basin for at least 1 year. So no matter what, when they take that fuel rod down, they stick it underwater in a very secure water basin for at least 1 year. And so that is to do two things. The first thing is to keep that fuel rod covered and cool. We want to make sure it's cold. We don't want to be supplying any heat energy or thermal energy to the fuel rod. The second thing is we use water as a way to absorb any alpha or beta particles that are being emitted from any other fission reactions that are spontaneously occurring, as these fuel rods are still going to be doing, because they have a lot of different byproducts in there. So it's very important that you store it for at least a year. After that, they take them out. So they take the SNF out, they dry them, and then they store them in a cask, which is basically like a concrete vault. Okay, so it's a beast. So they dry them and then they store them in this cask. Now the third part is there's two different options for this third part. You can either store them on site or off site. So let's look at on site first. So on-site storage. This is most commonly when you're trying to do something that's called a breeder reactor. Breeder reactor. A breeder reactor is essentially when you have a fuel rod that you use, then you take it down, you do the proper storage, but then you try to take it and you basically let it regenerate its fuel source. So that would be like if we took coal, okay, we burned it, we took the ashes, then we took it, we stored it underwater for a year, we dried it, we put it somewhere else, and then we left it there. And then slowly over time, it regenerated the coal. So it recreated the fossil fuel magically by itself. That is what a breeder reactor would do. We take a fuel rod, we store it underwater for a year, then we put it in a cask, and then we store it again, and then over time it eventually regenerates its fuel so that you could then take that fuel rod and put it right back into the reactor, and you have this cyclical system. So it's absolutely beautiful, but as you can imagine, it is much, much, much more dangerous. So the other option would be off-site storage, and this is definitely more common. And so for this one, for off-site, you have two different options. The first one is going to be surface level. So for surface level, basically what you do is you put these fuel rods just underneath the surface of the ground. So just underneath the surface of the ground. But this has two different components that are really negative. The first one is that it's human management. We have humans all around it, aware of it, monitoring it, but we are constantly watching it. But more importantly, this is at least a 1,000-year commitment. So we are saying that the next 9 generations of people, at least, are going to have to be responsible for the waste that we just buried and then died and left there and said, oops, too bad, bro, go ahead and take care of that. So that's definitely a negative. The other one, as you can imagine, would be deep underground, okay, deep underground. So we bury these babies way, way, way deep under the ground. So what's really nice about it is it's very, very, very low commitment, and we're not making anybody like our children's having to deal with the waste when we're long gone. So that's nice. But the big problem with it is that we have to make sure there is no way possible at all, that these SNF rods are exposed at all to water, because if it somehow gets into our groundwater contamination, think about how horrible that would be if we were constantly supplying a direct source of radiation to our underground water, which we then pump up to the surface and then drink without thinking about it. So they both have their negatives. Some are better than others. I'm not sure. Personally, I go back and forth. I think all three of them are decent options, but it's something that is one of the biggest issues when it comes to nuclear power plants. All right, that's all I've got for you. Take care of yourself.